Hey, hello, you're welcome to my channel. Now in this video, we want to find the domain of the following functions, alright? Good. Now in this video, I'm going to solve for the domain of the first example, and then for the second example, just to let you know how to find domain of functions, so that as we go further into tougher examples, you'll be already equipped with the knowledge of finding domain of functions. Good. Now for the first example, we have the square root of 2 minus 3x. Great. Now from in a previous video, I talked about the domain of functions, which meant the set of all possible inputs of a function. So I gave an illustration using a particular function where the function was not going to be defined due to the nature of the function at some point. Right? Good. So here we are having a square root of something, 2 minus 3x. Right. Now, for a square root function is only defined for non-negative inputs. What I mean by non-negative input is something like this. When we have the square root of, let's say, x, right? Good. Let's say we are talking about the output should be only non-negative numbers. Now, when we have square root of something like this, now, the square root is only defined when the radicand, that is the square root of that number, when that number is non-negative, that is when that number is either 0 or bigger than 0. Good. So if you talk about the square root of a negative number, for example, the square root of negative 4, there is no real number whose square will give us negative as a result, right? You know, when you have any negative number, if you take the square of that negative number to become positive, all right? Positive a squared. So there is no how you would take the square of a negative number and have a negative result. That tells us that the square root of negative numbers does not exist in a set of real numbers. So our interest will be that we want this thing to be non-negative. That is, we want it to either be 0 or bigger than 0. That is the radicand 2 minus 3x for that function to be defined in the set of real numbers. So that is the approach. All right? Good. Okay. Before you get right into it, if you've not subscribed to my channel, please do what to press the subscription button and turn on notifications. All right, as we continue further. So I've given the function a name, f of x, right? Maybe the second one also give it a name. Good. Now, in this function, we've got this. So as I said earlier, that this should be bigger than or equal to 0. So that's what we're going to do right away. I'm going to say that 2 minus 3x should be bigger than or equal to 0 for that function to be defined. That is what it means for the radicand to be non-negative. Great. Now, our interest here will be to get x on one side of the inequality and see the range of values of x for which that function will be defined. Good. So that will be by moving this 3x, negative 3x to the right hand side of the inequality. That will become 2 bigger than or equal to. Since this was negative, all right, we move it to become positive 3x. Good. The next thing we'll do here is to divide both sides by 3. That is just to make x to be alone, as I said. So we divide both sides by 3. Right? That gives us 2 over 3 is bigger than or equal to x. Good. Because this 3 will cancel out with the coefficient of x right there. So if 2 over 3 is bigger than or equal to x, that means x is less than or equal to 2 over 3. Right? You said 2 over 3 is bigger than or equal to x, meaning that x is less than it since it was bigger than, right? And since the equality sign follows, we just put it there for it to, so that we'll be in trouble. Good. So we are talking about all real numbers less than or equal to 2 over 3. Now, since x, we're talking about real numbers here. When we talk about functions, we're talking about real valued functions, and the domain are the set of real numbers. So the x here less than or equal to 3 means all real numbers less than or equal to 3. Now, since the domain is a set, I would like to write the domain of this function using a set notation such as this. So domain will be a set containing real numbers x, right? Such that, so maybe you get familiar with some symbols here. This is symbol belongs to from our study of sets, and then this long slash here shows the straight slash shows such that, right? So x, the set containing all x in R, such that x is less than or equal to 2 over 3, that is the domain of that given function. We're talking about all real numbers less than or equal to 3, because that's what we get from this. Good. Maybe we can also write this using an interval notation. When we talk about interval, such as this, we know that a set of real numbers start from negative infinity all the way down to positive infinity. That means the domain can also be written as from negative infinity all the way down to 2/3, and we put this is a parenthesis and this is a bracket, a closed bracket. Good. And now, when we talk about an open bracket here, this parenthesis, it shows an open bracket, meaning that this number, okay, the salient point close to it is not included. While this closed bracket shows that this salient point, the number close to it is included. Good. Now, when we talk about intervals of 2 points, let's say of point, let me not use letters for you, let me use just numbers so that it will make sense, all right? Good. Let's talk about from 1 to 5. Okay? Let's talk about integers, or let's just start from 1 to 5, real numbers from 1 to 5, then I open it at 1 and I close it at 5. This tells us every number starting from 1 to 5, with 1 excluded and 5 included, all right? So we can talk about numbers after 1 till 5. 5 will be included because it is closed at 5, but it is open at 1, meaning that we do not want the number 1 in there. So that is what the closed open interval and the closed interval, that is the function. So negative infinity is not a real number, so we can't even call that in, all right? Good. So the domain is this. Great. All right, let's do the second one real quick. All right, good. And now we've got a rational function when the function is in a fractional form, right? The numerator and denominator, we call a rational function with the numerator and denominator are just polynomial terms. All right, don't worry about that. Good. So this function is only going to be undefined if the denominator is equal to 0. So we talk about fractions, the denominator of fraction should not be 0. So what we'll be doing here is to equate the denominator to 0, find the value of x that makes the denominator to be 0 from that equation. When we get that value of x, we remove it from the set of real numbers, and the other numbers apart from that value of x form the domain of that given function. So what I'm saying is that we equate that denominator to 0, and then we find the value of x from here. So you just do that. This tells us that x is 1/2, just 1/2, all right? Good. Just by moving 1 to the right-hand side and divide both sides by 2. Great. Now, when x is 1/2, the denominator of that fraction will be equal to 0. You can check that out. That tells us that we do not want the denominator of the fraction. Okay, since we do not want the denominator of the fraction to be 0, then x, which is the real number, we do not want the real number called 1/2. Good. So we are going to be talking about all other real numbers except 1/2 in the domain. So the domain will be made up of the set of real numbers, right? Such that x is not equal to 1/2. It can be less than 1/2 and bigger than 1/2, but not the point 1/2. We can also represent this using the interval notation as, now, from negative infinity all the way down to 1/2. But you know what? We are going to exclude the 1/2. And again, we're going to unite this with from 1/2 till positive infinity. What this tells us is that since the real numbers since the set of real numbers start from negative infinity all the way down to positive infinity, with negative infinity and positive infinity excluded, then we talk about the point 1/2, which you do not want. So we want every other number except that point. So I'm using a union of two intervals where I exclude only the 1/2 and take every other point on the real line. Good. Okay, great. All right, let's move on to the number 3 question.